right, let's talk about a 19th century Scottish scientist whose name you might not know, but you absolutely should. I mean, his work is literally the reason your radio works, your Wi-Fi connects, and you can even see the colors on the screen. His name? James Clerk Maxwell. And to really get a sense of just how important this guy was, check this out. You know, someone once told Albert Einstein, the Einstein, that he stood on the shoulders of Isaac Newton. And Einstein was like, nope. He actually corrected them and said, no, I don't. I stand on the shoulders of Maxwell. Wow. So that just begs the question, right? Who was this guy that Einstein himself looked up to so much? And why isn't he a household name like Newton or Einstein? Let's dig in. And you know what? It wasn't just Einstein who thought this way. Time and time again, when you poll top physicists and ask them to rank the greats, the list is always pretty much the same. You've got Newton at number 1, Einstein at number 2, and guess who's always right there in third place? You got it. James Clerk Maxwell. So how does someone become, well, that brilliant? To really get Maxwell, we've got to go all the way back to his childhood in Scotland. This is where the defining feature of his entire personality popped up, pretty much the moment he learned to talk. Yeah, apparently from the age of 3, with this really rustic Scottish accent, he would point at anything and everything, anything that moved or shined or made a sound, and ask, what's the go of that? He just had to know how it all worked. And this wasn't just some kid phase. That question was basically the engine that drove his entire life. But, being that curious didn't exactly make him Mr. Popular. He was raised out in the country, so when he showed up at the big, fancy Edinburgh Academy, he was a total outsider. The other kids made fun of his accent and his homemade shoes, and they even gave him the nickname Dafty. So yeah, his genius was, let's just say, was flying under the radar at first. But of course, a mind like that can't stay hidden forever. I mean, he published his first scientific paper when he was just 14. From there, he just blitzed through the academic world. He was at the University of Edinburgh by 16, then on to Cambridge, and then he landed professorships at Aberdeen and King's College London, all before he even hit 30. Just incredible. And it was there, at King's College in London, that he put together his masterpiece. We're talking about a piece of work so big, so profound, that it's now known as the second great unification in the history of physics. So what in the world is a great unification? Well, it's kind of the holy grail in physics. The first one was done by Isaac Newton, right? He's the one who realized that the force pulling an apple to the ground is the exact same force keeping the moon in orbit around the Earth. He basically united heaven and earth under one law of gravity. And now, Maxwell. Well, he was about to do it all over again. So here was his big idea. For hundreds of years, scientists had treated electricity, magnetism, and light as 3 totally separate things, unrelated phenomena. Maxwell comes along, and with some absolutely mind-blowing math, he proves they're not separate at all. They're all just different sides of the same coin, a single, unified force he called electromagnetism. And the proof was just sitting there, right in the numbers. See, his equations predicted that these new electromagnetic waves had to travel at a very specific speed. So he took the best measurements for electricity and magnetism they had back in the 1860s, plugged them into his formula, and crunched the numbers. The answer he got was about 310 million meters per second. And he realized, wait a minute, that's almost exactly the speed of light. It was this huge light bulb moment, pun intended. It wasn't a coincidence. Light is an electromagnetic wave. And all of this incredible work was wrapped up in what we now call Maxwell's equations. Now, originally, it was this beastly set of 20 different equations. Later on, they got simplified down to the 4 elegant ones you see in physics books today. But these equations, they do so much more than just describe light. They actually predicted the existence of other kinds of electromagnetic waves, things like radio waves. They literally became the foundation for all modern electrical engineering. Okay, but get this. Maxwell's brain wasn't just stuck in the world of theoretical physics. As if unifying fundamental forces wasn't enough, his curiosity also pulled him into the very practical and even artistic world of color. Yeah, seriously. The same guy who rewrote the laws of physics also gave us the world's first durable color photograph. He took a picture of a tartan ribbon 3 times, once through a red filter, once through a green, and once through a blue. Then he layered those 3 black and white images on top of each other, and voila, a color picture. That basic 3-color process,
it's still the foundation for how your phone, your TV, and your computer screen make color today.
And the list just keeps going. This guy was a true polymath. He figured out that Saturn's rings couldn't be solid. They had to be made of tons of tiny particles, something we didn't confirm for over 100 years until the Voyager spacecraft got there. He helped invent control theory, which is crucial for modern robotics. He came up with the famous Maxwell's demon thought experiment in thermodynamics. He was even one of the first people to really get the ideas behind chaos theory. I mean, the sheer range of his intellect is just staggering.
So, what's the big takeaway here? Why should you care about these ideas from some guy in a top hat back in the 1800s? Well, the simple answer is because his work connects to, well, everything in our modern lives. Let's put this into perspective. We talked about Newton. Newton's great unification connected the physical world, apples and moons. What Maxwell did was unite the forces that power our technological world. He literally wrote the rule book for how electricity, magnetism, and light work. He handed that book to future generations, and they used it to build the world we live in today. And his influence just keeps spreading. You can draw a straight line from Maxwell's equations to Einstein's theory of special relativity. You simply don't get quantum mechanics without his work on light. And on a practical level, just think about it. Every single time you use your phone, stream a show, or hop on Wi-Fi, you are tapping into technology that is running on the exact principles James Clerk Maxwell figured out way back in 1865. You see, Maxwell's real genius was his ability to look at familiar, everyday forces and see the invisible threads connecting them all. He taught us that the universe is often way more simple, more elegant than we give it credit for. And that leaves us with a pretty cool question to ponder, doesn't it? What forces are we looking at right now, thinking they're completely separate, that some future genius, a new Maxwell, is going to come along and show us are actually all part of the same beautiful picture?